Dropping the bomb on evolution. Is this just clickbait, or is there a rational argument to be made that can explode the theory of evolution? Hello, Roddy Bullock here, founder of Creation Reformation and your host for today's video, where I intend to do just that. If you are an evolutionist, don't click away. I want to hear from you. If you think that I am wrong, you can reach me at the email address below. This email goes to me and me alone, and I will respond personally. For everyone, hang on. You are getting ready to see evolution explained like you have never seen it before. At Creation Reformation, we assert and defend a statement that we call the natural selection paradox, and here it is. Every current living thing evolved from a first life form solely by cumulative random evolutionary change. Now, we assert this as a logically valid yet scientifically absurd necessary truth of evolutionary theory. Let me explain. I am asserting that this statement must be true if evolutionary theory is true. That is, if the theory of evolution by natural selection is the true account for all current living things, then this statement can be shown to be true. But this statement is scientifically indefensible. Thus, the paradox, the natural selection paradox, because despite natural selection's role in nature, this scientifically indefensible statement must be true. Now let's find out why. We can speak in terms of necessary evolutionary change. That is the evolutionary change that the theory of evolution must account for if it is going to explain every current living thing. And we can start with this little diagram. I call this an icon of evolution. I'm not trying to make some fact statement with this diagram, but it is a convenient diagram that we are all familiar with to illustrate necessary evolutionary change. Specifically, what the theory of evolution purports to explain is why there is a genotype, a code of genetic building instructions inside of each of us that builds us as a phenotype, the thing built in nature by the genetic code of building instructions called a genotype. And what evolutionary theory purports to explain is how the genetic code of building instructions to build you as a phenotype evolved over time from something in the past that was not a human being. It's not important for our purposes what this was, some humanoid creature, but it was not a human being. And it was what it was as a phenotype because it has a genetic code of building instructions, its genotype to build it. So the necessary evolutionary change that the theory of evolution must explain is the change to genotypes and phenotypes to explain this change, for example. But it's not just this little progression that the theory of evolution must explain, it's this progression. Evolutionary theory purports to explain how from some first living thing back then, over time, in a populated line of descent, every living thing evolved, including you and me. Another way to say this is that every current living thing today, it exists at the end of a line of ancestral descent that is continuous all the way back to some first living thing. And of course, what I'm showing here is just representative organisms. Again, I'm not trying to make a fact statement, but if the theory of evolution is true, this line could be populated with actual organisms from this first living thing until now. And of course, these are the phenotypes, and each of these is what it is because they have a genetic code of building instructions to build them. So the theory of evolution, again, purports to explain how this thing, whatever it was what it was because it had a genetic code of building instructions to build it. This set of coded building instructions changed over time to become a different set of coded building instructions to build a different organism, and on down the line, you get the idea. But the evolution of genotypes and their corresponding phenotypes is the necessary evolutionary change that the theory of evolution must explain. Now, if this idea that every current living thing today, including you, can trace its ancestral lineage in an unbroken chain of organisms all the way back to some first living thing, if that strikes you as strange, I can assure you that it is not. It is a fact that must be true if evolutionary theory is true, and evolutionists often show that in the form of phylogenetic trees, and here is one. This phylogenetic tree shows up to the domain level how every current domain, and of course all of these, here's animals here, could be extended out to every current living thing. Each current living thing out on the end of these twigs and branches of this phylogenetic tree can trace an unbroken chain of ancestral lineage all the way back to some first living thing. Again, this is simply a fact of evolution. If we take you, for example, as a representative current living thing, there is an unbroken chain of ancestors all the way back to this first living thing, and we could populate that with representative dots. These are showing the same thing as I showed in this diagram up here. The idea is that between this first living thing and you is an unbroken chain of organisms, each evolving from the one before it. This is standard evolutionary theory. Again, the necessary evolutionary change that evolutionary theory must explain then is this evolution of continuous genotypes that have their corresponding phenotypes. Now, let me remind you of the natural selection paradox that I am defending. And I'm going to say that this is a necessarily true statement. And if I can show that, then it will render the theory of evolution duly exploded. Now, let's continue our inquiry by asking this question. What evolutionary mechanisms account for the evolutionary change from first life to all current species? I use the term species here in this video. I'm more precisely talking about all living things, you, me, your dog, and your cat, okay? What evolutionary mechanisms account for that change? Now, we can look at this little diagram here. Broadly speaking, evolution is just change over time. That's often emphasized by everyone defending evolution, and I agree with that. And specifically, it's change over time from back then to now in the biological context to explain how something back then changed over time to become you and me, but not just you and me. Every current living thing today, if evolutionary theory is true, can trace its ancestral lineage back to this right here. Recall our phylogenetic tree. Everything alive today extends at the end of the twigs and branches of this tree and can trace a line of descent all the way back to this first living thing. So if we ask this question right over here, what are the mechanisms of evolutionary change? And if we search that online like I did recently, you will find, for example, this AI overview that provides 5 mechanisms of evolutionary change. Now, if you do this, you may find more or less. Some lists will include things like horizontal gene transfer or epigenetics, but it doesn't matter. We are going to see that the way we are going to evaluate the theory of evolution, it doesn't really matter what you add to this list. Conceptually, it's not going to change the outcome. So if we look at this, we are going to make sense of these various mechanisms of evolutionary change by dividing them into 2 simple categories. And you will see why in a moment. We are going to talk about changes that happen at the organism level and evolutionary changes that happen at the population level. This is extremely important to understand. All mechanisms of evolution are not the same. They don't operate the same way. They have different functions and they have different outcomes. And when discussing whether the theory of evolution can explain all current living things, often the discussion gets sidelined because people are talking about changes that operate at the population level and others are talking about changes that happen at the organism level. They both operate in nature and we are going to see why. At the organism level, the mechanisms of evolution that operate at the organism level explain the production of new and different organisms in nature. It is important to understand that if the theory of evolution is going to account for all life forms that started here, there must be new and different organisms produced in nature. Otherwise, whatever started here would still be here, just in greater numbers. But we know that, in fact, there are now many different species. And if evolutionary theory explains these current living things, then there must be production of different organisms in nature. And we know today, according to evolutionary theory, that these new organisms arise in nature because of genetic mutations, more specifically, or more generally, genetic variations, but primarily mutations that produce variation in offspring. That is where new organisms come into nature as the raw material, as we're going to see, for population level mechanisms. And we know today that the genetic mutations that arise in nature do so by changed genotypes in offspring primarily. So the genotype gets passed to offspring with changes, primarily mutations, and it produces a changed phenotype, the thing built in nature, the organism itself. Okay, this is where these are the mechanisms of evolution that do this. And again, I just want to emphasize, because this may be strange to many of you, when we talk about changed genotypes and changed phenotypes, in this chain descent with modification from a first living thing, every dot here representing an organism, of course there would be millions and millions, but every dot that produces the next dot in line is an evolution from the one previous to it, and it is an evolution because it has a changed genotype and a changed phenotype. Now, we understand in evolutionary theory today that the organisms that are produced by changed genotypes and their changed phenotypes in nature arrive in their environment, in their population, fit and adapted to survive or not, okay? The genotype that gets passed to them as offspring that generates their phenotype presents them in nature either fit or adapted for their environment or not. Okay, this happens at the organism level, and it must happen before anything can happen at the population level. At the population level, we are looking for the fate of different organisms. What happens in nature? What happens in the environment? What happens in populations when these variations of genotypes and phenotypes enter into nature? And we know today that the primary mechanism that operates at the population level is natural selection. Natural selection is the operation in nature that we understand determines whether or not these genotypes and phenotypes produced over here as fit and adapted survive and reproduce or not. So we have mechanisms of evolution that operate at the organism level to produce new organisms as the raw material for natural selection to operate on with survival and reproduction or not. So when this happens, organisms get passed into the population. If they survive and reproduce, then they go back to produce new organisms. And according to evolutionary theory, this process has operated over and over and over again to produce every current living thing today from this first living thing now. Now, what we can find this interesting is if we go back to our list of mechanisms of evolutionary change, here are our 5 mechanisms. We can simplify these mechanisms by recognizing that some of these operate at the organism level and some operate at the population level. For example, these 3, mutation, gene flow, and sexual reproduction, whatever they do, whatever their actual mechanism is in nature, the result in nature that's important for evolution is that they contribute to the production of different organisms. And whatever these 3 do, the end result is that there are new genetic codes, new changed genotypes that produce variation in offspring changed phenotypes in nature. Okay, so we can simplify these mechanisms by just thinking of any mechanism that produces changed genotypes and phenotypes in nature. And of course, over here, genetic drift and natural selection, whatever genetic drift does, it plays a role in determining the fate of different organisms. All right, so we are going to consider these kinds of evolution in an illustration, an actual illustration from history of natural evolution and natural selection in action. And going forward, we are going to limit our discussion primarily to these concepts: genetic mutations producing variation in offspring as the production of new organisms, because regardless of what else gets entered into this category over here, the bottom line is it makes no difference in nature unless somewhere along the line there's a changed genotype that produces a changed phenotype, okay? And over here, we're going to limit our discussion to natural selection, because regardless of other population level mechanisms like genetic drift, the only one that really matters in evolutionary theory is natural selection. Darwin wrote a book called On the Origin of Species by Means of Natural Selection. The theory today is called evolution by natural selection. So we are going to discuss natural selection. If we can find that natural selection's role is not contributing, in fact, to the evolution of every current living thing today, as the natural selection paradox alleges, then we will have exploded the theory of evolution, which is, of course, our goal. Now, let's take what we know about kinds of evolutionary change and let's look at how this plays out in nature using an actual example that appears in textbooks, biology textbooks, evolution textbooks. If you've ever taken a class in evolution, you will be familiar with the example of the English peppered moths. Now, this is an example of natural selection and an example of evolution in action based on an actual historical event that happened in England in the 19th century. And the way the story plays out is there was a time in the early 19th century in which there was a peppered moth of some variety and some color, and it was what it was because it had a genetic code of building instructions to build it. And over time, this genetic code of building instructions experienced a mutation on the gene that codes for color. And at this point, there were 2 genetic codes different based on the gene that codes for color. One of them had a gene called an allele, a gene that codes for a specific trait in an organism, and the phenotype of the organism is called an allele. We're not going to get too tied up in these terms, but that is the technical term for a gene that codes for a trait, in this case, color. And now there are 2 different genotypes in nature producing 2 different phenotypes in nature. And of course, this is what we understand from our previous discussion. What must happen for evolution to be true is there must be some production of new genotypes that produce new phenotypes. And around 1850, it was noticed that in the population in this part of England, most of the moths were light-colored, but there were a few dark-colored moths appearing. But at this time, in this part of England, the Industrial Revolution had caused buildings and trees to be covered with soot, so that in the natural habitat of this population of moths, they like to land on buildings and trees, we are told, the light-colored moths stood out more starkly for predatory birds, and dark-colored moths were more camouflaged from these predatory birds, so that by the turn of the century, around 1900, the population of moths had changed so that now there were more dark-colored moths than light-colored moths. And this is an example of evolution. And if the environment had not changed by cleaning up the pollution from the Industrial Revolution, it is not inconceivable that by around 1950, in fact, the light-colored moths could have gone extinct and the population would be only dark-colored moths. And in fact, natural selection is used as an explanation, as we will see in a few moments, with respect to long and short-necked giraffes. It is used as a reason for organisms going extinct. Now, I'm going to introduce a concept, a metaphor for natural selection that's operating here that I want you to grasp and understand, and that is why I drew this line this way. Natural selection can be understood as operating in nature like a filter. In this case, natural selection acted as a filter so that as time went by, the light-colored moths tended to get filtered out, and what ended up on the other side as filtrate, so to speak, is dark-colored moths. Now, this idea of natural selection acting as a filter is not new to me. This is actually a standard metaphor used by evolutionists. And in fact, if you do an online search, you will find an AI overview like this. Natural selection is a process that acts as a filter, removing traits that are less helpful for survival and reproduction. And that's what we see in this example of the peppered moths. The trait of light color was less helpful for survival and reproduction, and because of that, natural selection tended to filter out that trait and leave dark colored moths. In fact, if you look at a definition of natural selection today, it will say something like a change in the frequency of alleles, for example. It will be some confusing language, but it's using this terminology of alleles, and all it's saying is that what natural selection does is change the frequency of alleles. Over here, we have lots of alleles that produce light colored moths and a few alleles that produce dark colored moths. And over here, again, I'm showing all dark colored moths. Let's take the case where the light colored moths go extinct. The frequency of light colored moths is reduced to 0, and the frequency of dark colored moths is increased to 100%. So that's all that definition means. Let's look at a generic filter with some fictional generic representation of organisms in nature. Again, this is clearly fictional and made up, but it illustrates the idea of this filter in nature. Let's say that in nature there are large blue organisms and small green organisms. And let's say that in the environment in which they exist as a population, for some reason this environment favors small size and tends to not favor large size. What we'll find over time is that the large size organisms are filtered out, and the small green organisms are free to go through unchanged. Okay, this is the idea of this filter. Let's look at an actual example involving giraffes. We are told that in the past there was a time when there were long-necked giraffes and short-necked giraffes in the population, and they existed together. But at some point in their time existing together, the food source, the leaves that giraffes like to eat, became limited to the upper portions of trees. There were no leaves at the lower portions of these trees for the small-necked giraffes to eat, and natural selection as a filter of starvation caused the short-necked giraffes to go extinct, and today we are left only with long-necked giraffes, so we are told. What this example is showing is that the short-necked giraffes were rejected by the filter of natural selection. Rejected is the term Darwin used to describe natural selection. Natural selection rejects organisms that are not fit for their environment, and it shows that the giraffes with long necks go through preserved to survive and reproduce. Preserved is Darwin's term. The original title of his book, On the Origin of Species by Means of Natural Selection, or the Preservation of Favored Races. So Darwin uses the language of rejection and preservation, and we are told that this is the operation of natural selection that left us with long-necked giraffes today. Let's quickly look at one more example that we see in textbooks, and it involves green and red bugs. And in this case, it wasn't starvation, it was predation, similar to our peppered moth example. It seemed that birds, for some reason, like red bugs more than green bugs, so the filter of natural selection worked such that the red bugs were rejected by being eaten by birds. The green bugs passed through preserved to survive and reproduce. Now let's go back to this example, this representative metaphor of this filter in nature, because it's going to illustrate an important fact of this filter of natural selection. And let's ask the question, what happens if we remove the filter of natural selection? Okay, if we remove the filter of natural selection, what we are going to find is that in addition to the small green organisms that made it through the filter as if it was not there, we would also have in the population these same large blue organisms. In other words, the population continues unchanged. In addition to the green organisms that existed, they will be in the population with these large blue organisms. Okay, let's look in terms of our giraffe. What if the starvation never happened? What if the food source for small-necked giraffes and long-necked giraffes never changed, so that this starvation filter is removed? It should be clear to you now that what we would find is that in addition to the population of long-necked giraffes that were unaffected, and they in fact didn't even know there was a filter of natural selection, they would be in the company of all these short-necked giraffes, and they would still be here today. That is an example of the filter of natural selection. So let's go back to our example here. Here we have a filter operating that is going to filter out light-colored moths and let dark-colored moths go through. Now, this is an example of natural selection. This whole process is an example of evolution by natural selection. Let's look at what's happening here. Over here on this side, in the production of new organisms, we have genotype and phenotype changes. And we know, according to evolutionary theory, that the changes that produce new genotypes and phenotypes in nature are purely random. I have here random genetic mutations, but it's any random genetic variation or change. But the idea is that new organisms are produced in nature as raw material for natural selection by random evolutionary mechanisms. They are all random. Everything over here is random. And once these organisms get into the filter of natural selection, it's important to understand what's happening. None of these organisms are changing. The white moths that started over here are the same, light-colored moths over here are the same light-colored moths over here. The dark-colored moths over here are the same dark-colored moths over here. There's no change to any organism. There's no change to a genotype. There's no change to a phenotype. Natural selection does not alter organisms. They do not modify organisms. Natural selection does not adapt organisms. The only thing that's happening in natural selection is the change in the gene or allele frequency, as we looked at earlier, the numbers, the proportions. One way to look at it is natural selection is simply population demographics. That's all it's doing. It's just changing the relative numbers of already existing organisms that were produced solely by random genetic changes. All right, let's put this little diagram up here, and we are going to look at some propositional statements that we can make based on this diagram. We are going to make we're going to make 4 propositional statements that are going to be the foundational statements for the 5th statement that is going to be the natural selection paradox. Let's see if we can do that. Let me see if I can explode the evolution, theory of evolution right before your eyes. Let's start with a first propositional statement, and here it is. The theory of evolution by natural selection posits a mechanism or process for how new genotypes and phenotypes appear. I want to say are created in nature, but of course that term is problematic for a lot of people. Let's just say they appear, they are produced in nature over time. Okay, the mechanism that is said to do this in the theory of evolution by natural selection is the reason why we can say it caused the change over time for all of these, because again, if we did not have this mechanism for producing new genotypes and phenotypes, then we would just have more of whatever we started with. But of course, we know we're here. All right. What we know from our discussion is that the only evolutionary mechanism that explains the appearance of new genotypes and phenotypes in nature is heritable genetic change passed from parent to offspring. That is the only way any new genotype to produce a phenotype appears in nature. It appears inside the phenotype as offspring from a parent organism. Okay, now we can also say that these new organisms that are the raw material for natural selection, the new changed phenotypes arise on Earth solely by random, unguided, purposeless genetic variation. That's important for you to understand. There is no other means for getting new organisms in nature except by random, unguided, purposeless processes, specifically genetic variation. All right, let's move to 2. The mechanism of heritable genetic change, what's happening right here, explains how certain new genotypes and phenotypes arrive on Earth fit in nature to survive and reproduce and others not. This is important. Again, it's a little repetitive here, but it's important for us to understand that these organisms arrive fit and adapted or not. Natural selection over here does nothing to alter fitness or adaptation to the environment. Okay, so we can understand that these new organisms produced by heritable genetic variation in each generation appear on Earth with inherited traits or features that render them fit in their environment or not. And this heritable genetic change alone provides fitness of new organisms. Again, I'm driving home this point because we need to dispel this notion that somehow natural selection renders some adaptation or changes or alterations to already existing organisms. It does not. Let's move to number 3. The theory of evolution by natural selection posits that fit organisms are preserved to survive and reproduce as natural selection eliminates the unfit organisms. Okay, remember our example of the giraffes. The fit organisms are preserved to survive and reproduce, and the short-necked giraffes were eliminated as unfit. And it is because of their inherited fitness traits. If we substitute here short-necked and long-necked giraffes, they are short-necked or long-necked because of the genetic code that built them, okay? And they can survive and reproduce to pass on heritable traits on the other side of this filter, including with additional genetic variation. But only fit organisms are preserved to survive and reproduce. Again, some of these concepts should be fairly elementary to you by now. Let's move on to number 4. The theory of evolution by natural selection posits that only preserved organisms populate the unbroken chain of evolutionary descent from a first life form to every current species. Okay, if we look up here, it is only fit organisms that are preserved, and they form part of an unbroken chain, unless they get eliminated in the future, of every current living or some current living thing that's at the end of their chain of descent. Okay, we can understand that, again, like a filter, natural selection rejects unfit organisms by eliminating them from the population, and it preserves fit organisms to pass through unchanged to reproduce. Again, I'm going to stress this again. The organisms on this side of the filter of natural selection, the individual organisms are the same organisms that started over here. There are nothing new in nature appears except population demographics, just different proportions of what existed based on random mutations producing new organisms here. All right, so this is a little long. Let's read it. Natural selection operates on populations previously changed and existing fit phenotypes in nature. Existing genotypes and phenotypes produced by genetic variation are preserved to reproduce unchanged in their lifetime. All right, Let's look at these four statements. I told you that this is going to lead us to the fifth, which is the natural selection paradox. Let's just consider these four statements that we've made in light of this diagram that we earlier said is a fact of what evolutionary theory explains. That from some first organism in an unbroken chain of descent with modification, every current living thing exists today, including you. All right, let's look at our four statements and see if we can see how that's true from this diagram. Let's start with number 4 and work backwards. Number 4 states that only preserved organisms populate this unbroken chain of evolutionary descent. And that should be fairly obvious. In order for any successive organism, let's just take any dot on here, for it to evolve from the dot before it, so to speak, the organism before it, the organism before it must have been preserved to survive and reproduce. This should not be controversial. Only preserved organisms populate this unbroken chain. Let's go to number 3 here. We know that it's fit organisms that are preserved, and natural selection eliminates the unfit organisms. Now let's think about what this means in view of this diagram right here. Every one of the organisms that populates this line was by definition fit to survive and reproduce because it produced the offspring that follows it on this line in this line of evolution. And by definition, nothing on this line was eliminated by natural selection. Natural selection is operating in this diagram. Natural selection is operating in nature, but it is not operating to eliminate anything on this line. It is eliminating things that are off this line. So if we had a full diagram of all the branches, including the branches that went extinct, we would see where natural selection operates to cut off certain lines, but it did not operate in this line. Very important. You may want to consider that for a few moments. Let's go to number 2. We know that it is heritable genetic change that explains how certain new genotypes and phenotypes arrive on Earth. So every one of these dots, again, as a stand-in for an organism, there would, of course, have been millions and millions of organisms in this line if evolutionary theory is true, so these dots are just representative. But if the theory is true, then it is only heritable genetic change that explains why any one of these dots evolved from the one before it. That is the only change that happened to produce it. And if we go to number 1, importantly, we know how these new genotypes and phenotypes appear. They appear because of random changes to genotypes in the production of offspring. Okay, there's no other source for these. Now, if we take all of these statements together, we can understand, here we are, the fifth, this statement, despite natural selection's role in nature, okay? Despite natural selection removing things off of this line, every current living thing, let's say you, evolved from a first life form right here, solely by random evolutionary change. Think about that for a moment. This is remarkable. This is a remarkable fact. In fact, it is a logically valid fact, but it is scientifically absurd, as we said earlier, but it's a necessary truth of evolutionary theory that the only evolutionary change that explains each succeeding organism on this line is random genetic change in the genetic code that went into each successive organism that produced each successive phenotype that itself went on to survive and reproduce the next one. Now, of course, this is the natural selection paradox, and based on these statements, I believe that I have supported it as a statement that must be true if evolutionary theory is true, and we can ask, why does this matter beyond the obvious reasons? Here is why this matters. I have called this statement scientifically indefensible or scientifically absurd, and the reason for that is because there is no natural law, there's no scientific principles, there's no reason to believe in nature that this statement can be true to explain how evolutionary theory's cumulative random genetic changes can result in millions of working building instructions today. Now, if you want to do a deeper dive into this, I am often accused by evolutionists of, at this point, making an argument from incredulity. Because believe it or not, knowledgeable evolutionists will agree that this statement is true. But when I ask them what natural law or scientific principle can make it true, I get accused of an argument from incredulity. And because of that, I have produced a video called Defending the Natural Selection Paradox Against the Argument from Incredulity. And there you can find more support for the natural selection paradox and why, in fact, it must be true but cannot be supported by any known laws of physics or chemistry or nature. So if you are going to believe that the theory of evolution explains your existence, you cannot call it the theory of evolution by natural selection. If it is a true explanation for your existence, it is the theory of evolution by cumulative random genetic change alone. And if you want to believe that your existence is explained by cumulative random genetic change alone, I don't think there's anything I can do for you. But for the rest of you, I hope that you will join me in rejecting the theory of evolution by natural selection as an explanation for your existence. So here we come to the end. I want to draw your attention to this website, naturalselectionparadox.com, where you can find more information, including links to more videos. And of course, here is my email address. If you would like to contact me and tell me why I'm wrong, you are welcome to do so. Start by explaining to me why any of my 4 propositional statements are false, and then why the natural selection paradox is false. Or if you'd like to take a stab at explaining why the natural selection paradox can be supported scientifically and thus let the theory of natural selection by evolution live another day, have at it. I welcome your email. But for now, I am going to sign off. There should be on your screen a link to this icon where you can subscribe to this YouTube channel. I hope you will, and as well a link to an interesting video that you might like. But for now, I'm going to say good day and goodbye.